Hello everyone and welcome to another Espressif webinar. Today we're going to talk about Matter. The topic is what is new in Matter updates and developments. For today's webinar, we have Anant Gupta from Technical Marketing Team. How are you, Anant?
Yeah, I'm good. How are you, Pedro?
Yeah, I'm just fine, thank you. So before we start, I have just a brief announcement to do. Recently, we announced the developer portal. So we have a lot of content there, not only about Matter, but for many other products and solutions we have. So I invite you to visit developer.expressive.com and check out all the content we have there. So now we can go to the webinar we have prepared for you today. So Anand, the stage is yours.
Yeah. Thank you, Pedro. So welcome everyone. Thank you for joining today's session in our Matter webinar series. It's been a while since we last had this session, but there have been tremendous updates and developments, both from the Connectivity Standard Alliance as well as Espressif regarding Matter and its support. In this webinar, we will talk about a few of these updates and their relevance. We will also talk in depth about the new developments from our side to help streamline and simplify your Matter journey further. We have broadly broken down this session into 4 categories. At first, we will quickly recap what we did and covered over the previous sessions. Then we will talk about the updates in the Matter specifications in version 1.3 and in the future upcoming releases. Next, we will talk a bit about our low power Matter connectivity in terms of intermittently connected devices, or popularly known as ICD. Lastly, we will cover the different solutions around Matter from Espressif. So, what is Matter, right? So, we will just do a quick recap about Matter and its advantages, as well as some of the requirements which it has on top of the traditional development requirements for any product. So, Matter is an industry unifying standard defined by the Connectivity Standard Alliance, formerly known as the ZigBee Alliance, and it has member companies from device makers to silicon vendors to ecosystem players. The main aspects around which Matter is built is that it's simple, which basically comes from the ease of use for the end consumer, as well as ease of development for manufacturers. It is reliable, basically it works on the local network, it has a certification process, so every device which is in the market, which is Matter certified, is gone through a interoperable test and unified structure, so make it seamless and reliable. It is secure, which basically means there is authentication that the device is really coming from the source it is meant to. And then it is encrypted communication over the communication medium. And then there are provisions to provide OTA, which basically means if there is any vulnerability in future detected, it can be patched. It is an open source system. So basically, every development which is there, there is a base or a source methodology which is implemented first approach. The standard is built on top of IPv6, supports Wi-Fi, Thread, and Ethernet for communication, as well as BLE for commissioning. So how it helps, right? So Matter brings together ease of use for consumers. It's focused on end consumer with multi-admin support for either interoperability. There are automations possibilities due to the features like device-to-device communication. There is device sharing. There is ease of deployment for the device makers, and then there is innovation scope because of some new capabilities which are introduced. And then what device makers have the biggest advantage is that they have to only support a single ecosystem when they are doing their development. So it tremendously reduces the cost and the timeline for device makers to adapt to their devices. And then from the ecosystem point of view, it provides interoperability, and basically you can switch between ecosystems. It's scalable and it is open source. So few of the requirements which Matter adds, which are not particularly in any other development. So first one is the product certification. So every Matter product which goes into the field has to be certified. So certification helps to ensure the compliance, basically helps to validate that whatever we claim, the interoperability, it really works. And then you can, of course, use the Matter logo for your marketing as well as to differentiate your product. And then it validates that you have the seamless interoperability across the different ecosystems. How it is achieved? It is achieved through a rigorous testing process through a certified CSA lab. Each product requires a different certificate declaration, which is issued to you once you have completed the certification. The other requirement which comes is the device attestation, which is basically the unique identification of your device. So every device has to carry a DAC certificate, which is signed by a CSA approved PAA. It includes a private key and acts as the device identity. The commissioner can establish the trust in the device when it issues receives the DAC, and then it validates it with the DCL that it's a valid DAC for that particular kind of device. So each device needs to be programmed with this unique passcode. And then the DAC provisioning requires infrastructure updates or equipment setups in the manufacturing, which adds a bit of manufacturing capabilities to be complicated. How to get certified? So there are primarily three ways to get your device Matter certified. The first one is, of course, you have to go through the product testing based certification. This could be for the individual product or a family of products. The next is certification by similarity, which basically means if you have already a certified product and you have very minimal changes, just maybe like casing or some minor updates, so you can do certification by similarity. And then the third one is certification transfer program, which is basically meant for ODMs or OEMs, which already have a device manufactured, which they want to sell like white labelable, and then they can actually transfer the certificate to other vendors. Few of the manufacturing considerations which we have to consider or take into account when we are going to build a Matter certified device or manufacture it in our own factories. So basically, you have to have your own DAC provisioning infrastructure built in. The factories needs to be secured to be able to work with cryptographic material. Then the PKI as a service platform can provide DAC, but require equipment in your manufacturing factory, which requires a heavy upfront investment and time. And then there are unique data programming that can take more time for each device on the manufacturing line. So that was a quick recap of what we have already covered in our previous sessions, just to bring you on page if you had some loss of memories. Now next, what we will do is we will talk about the updates on the Matter specifications since last we discussed. So we have had a Matter 1.2 specification, which was officially released earlier this year. It contains some new features to enhance user experience, which we will discuss now. And then later we will talk about some future upcoming features, which will be released in Matter 1.4 on further. So the first feature which we will talk about is command badging. So command batching is basically what it sounds. It's batch multiple commands into a single message when communicating with Matter devices. What it does is it basically helps to minimize the delay between the execution of those commands. So when you have to send multiple commands, instead of sending each command in a different packet, we can now send them together, clubbed together in a single message, which basically helps us to avoid multiple network latency, helps us to reduce the congestion on the network interface as well. So one particular example could be like doing it over a Matter bridge, so which has like connected to maybe 20 devices which are brought over to the Matter network via the bridge. So with this, we can actually have a single command going to the bridge, which tells the multiple devices to provide a more synchronized experience on how they operate. Right. The other feature, which is a much awaited feature, is called the scene control. Scenes have been part of most of the ecosystem since quite some time, but they were not part of Matter specifications yet. With version 1.3, it has been introduced as a provisional feature. So what Scenes does is it provides a uniform method for product makers and platforms to set, read, and activate states of devices. When I say states of devices, basically means you can have a desired state of combining settings of multiple different uh, devices with a single command. What it does is basically it reduces the number of commands which are required to execute the scene and improves responsiveness. So basically, you can set a scene like, okay, I am going into set my living room as a movie theater, right? So what it can do is it can basically maybe roll down your curtains, dim your lights, open up your projector, or turn on your air conditioner to a certain temperature. So with just a single command that will say, okay, scene, turn my living room to a theater, and you can have all those settings executed. So yeah, it's a very useful feature, I would say, in overall user experience. Next, we have a new cluster which was added, which was the energy management cluster. So, which is basically it introduces new energy reporting capabilities for each and every Matter device. So, every device can choose to include this cluster, and it can enhance our report actual or estimated measurements of some things like instantaneous power, current consumption, the voltage it's operating on. It can choose to do real-time reporting, or it can do some averages or generation or predicted energy consumption over time. So overall, a very important feature if you are looking from more green energy or climate point of view. So each and every device can then share its energy consumptions, and yeah, and it can be lead to a very good data to help improve the overall current consumptions of your devices at home, or yeah. There are quite a few Matter devices which have been released. So there's a focus over water management devices as well as some kitchen appliances. So a few device tags which have been added in version 1.3 is basically microwave ovens, extractor hoods, cooktops, convection ovens. So these are a few on the kitchen appliances side. On the generic appliances side, laundry dryers, which were missing. So we had laundry washers already part in Matter 1.2, but now we have the dryers as well, which have been added as a device type to be supported in version 1.3. And then a big one is the EV charging. So this basically helps you to add electric vehicle charging plugs to the Matter ecosystem. And then, as I mentioned, we have a lot of different device types like walls and stuff in the water management cluster. Okay, so these are the new devices and the features on version 1.3. Next, we will talk about a few features which have been expected to be supported in upcoming releases. We see there are implementations around these features and updates in the open source repository for Project Chip, which is the open source repo for on GitHub for all development and base examples. The first one we will talk about is ecosystem to ecosystem, or E2E. For better clarity of its meaning, it's going to be called enhanced multi-admin. So this feature is one which has been added after considerable feedback and understanding of pain points in actual user experience and adoption. And it really signifies the importance the Alliance puts in interoperability. So what is E2E? So or enhanced multi-admin. So it's a feature simplifying device management across various smart home ecosystems. It enables seamless interactions between different platforms, improving user experience. Uh, some of the key features for it is Fabric Sync. which basically automates the process of making devices available on multiple ecosystems, reducing manual setup. So if you remember, right, so the one of the major pain points which the people face in multi-admin support is that suppose you have 20 devices added onto one ecosystem, and now you want to share them with another ecosystem, right? You have to do it manually and give access to one by one for each devices. But now with enhanced multi-admin support, you could actually, with a single click of acceptance, share all your current devices and your future devices to a different ecosystem in one go. So what it helps to do is, once you have enabled this, you add a new device in one ecosystem, it will automatically sync to these other ecosystem which you have given this access permissions to, right? So that's a very, very critical feature called Fabric Sync. There are going to be a few more features like Joint Fabric and Fabric Bridge, which will be upcoming in the near future as well. So these would be methods to further streamline device sharing across ecosystems. So as I mentioned, the major benefits are eases the device handoff between platforms. So you can, with just with a single acceptance, can actually make a live sync of the two ecosystems. So it enables existing and new devices to automatically connect to the multiple ecosystems. Next, we will talk about the enhanced infrastructure, which is going to be part of the future releases. So we will talk about HRAP, which is home routers and access points. So it's like devices like your routers, modem, setup boxes. So there are now device types which are officially Matter compliant. So these have been added, and they will serve as the backbone of the Matter network in your smart home. They will simplify the smart home networks by securely storing and sharing thread credentials. How do they do that? Is by acting as the network infrastructure manager, which is known as the NIM. So as part of the HRAP, NIM will improve home network management by handling thread credentials and sharing of them to ensure whenever there is a new thread pod or router, it can get the thread network credentials and can be easily adopted to the existing Matter network. This also allows non-thread controllers to commission new devices onto the thread network. The other important feature which is on from the network side is secondary network interface. This is primarily important because it allows your device to use an alternate network when the primary network is unavailable. So this basically means, suppose your device is right now connected over Matter over Wi-Fi, but it also has the capability to connect over Matter over Thread. So you can have a primary network and a secondary network. So whenever there is the primary network available, the device will communicate over Matter over Wi-Fi, say. And suppose there is some network outage or some unavailability of the Wi-Fi network because of range or anything, it can fall back onto the thread network to maintain the uninterrupted connectivity, and it's vice versa. So if thread network is unavailable, it can piggyback to the Wi-Fi network. And what it helps is it helps to provide a reliable communication and functionality even in challenging network conditions, because you have a fail-safe kind of a mechanism of having a secondary network. So a few of the new device types which we expect to be coming up soon. So water heaters, solar power, battery storage devices, heat pumps, and then some mounted controls on existing devices. Okay, that brings us to the next section on our webinar today. So we will briefly now talk about intermittently connected devices, or ICD devices, for low power battery operated use cases over Matter. So ICD mode basically is used to extend the battery life for devices. So there are a lot of device types like sensors and thermostats or temperature sensors, occupancy sensors, which do not need to be alive all the time, and they sometimes needs to have very, very good battery life, right? So the ICT manager uses the subscription report synchronization and open thread to allow devices to sleep while preserving matter sessions. So basically, the device can go into really low power modes and still maintain their matter sessions, even though they are no longer on the network. So the ICD devices basically operate in two modes, the active mode and the idle mode. So when the device is in active mode, the ICD is set to a fast polling interval for maximum responsiveness. So when the device is alive, it is acting in the fast polling interval. Once the active mode is triggered, it will stay for a minimum of active mode interval, which basically allows us to communicate with the device during that period if there are any messages for it or if there is any message from it. That can be done during this active period. And when the active period is elapsed and then there is no active communication or no active state for the device will switch its operating mode to idle mode. Similarly, if the device is in idle mode, the ICD will poll its associated router for its slow polling interval to see if another device has tried to communicate with it while it is sleeping. If there is no event which has occurred, the ICD device stays in idle mode for the entirety of the idle mode interval. So there are two modes of operation. So this is basically a short idle time and the long idle time. So this basically is defined by how much time the device will remain in idle mode, and that basically dominates on how the device wake up or the device communication happens. So the boundary is 15 seconds. So if the device is idle for less than 15 seconds, it will fall under the short idle time or the SIT category. This was introduced with version 1.0, but it's really practically was supported from version 1.2. So this device looks like a very regular matter device. It doesn't differentiate. And it is the standard client initiated communication. So there are optimizations to synchronize subscription intervals to reduce the amount of time it requires to get active. Whereas the long idle time or the LIT devices, which will be supported in upcoming releases, it goes offline for more than 15 seconds. Could be hour, could be couple of hours, right? But definitely more than 15 seconds. And it has a new paradigm of device checking in to the client. So the device will actually initiate the or check in to say that, oh, did anyone try to communicate with me? And yeah, to the client. And of course, it requires the client to have the support as well. So only clients which are um, version 1.4 and later will be able to support LIT devices. There is also a concept of dynamic LIT SIT, which basically means the device can mostly operate in one of the modes LIT SIT, but has an option to act in the other mode, like SIT LIT. So a typical example could be like a smoke detector, which may be mostly in SIT, which is in short interval time mode, but can fall back to LIT when there is power lost, so and it's running on battery, right? So just like yeah, so it piggybacks to conserve battery life, so it will have a longer interval. Okay, so that was about the low power ICD devices. Next, we will talk about the Espressif Matter offerings. So Espressif has a wide variety of support of products as well as solutions to support the Matter product development. So we will quickly recap on what we have already known. So basically, Espressif hardware and software enable building all types of Matter devices, including Matter Wi-Fi end devices, Matter Thread end devices, Thread border routers, and Matter bridges to bridge with other products. So this was what we have already covered in the previous sessions, especially in session 2, which we went through building a Matter devices, as well as session 1, in which we introduced all the different products or offerings at that time, right? But now, since some time has passed, there has been a lot of development. There have been new uh, updates from this connectivity standard alliance as well, and then we have some few offerings which have improved. So, so we will try to categorize these devices into few ways, or basically, so how a development cycle would look like for a Matter solution, right? We broadly categorize them into three different categories. So first is, of course, is the development, right? You need to develop your product. It requires to write your application, build your hardware. So all these aspects of this. But apart from that, as we introduced earlier in this session, right, we require two more additional requirements to have a complete Matter solution, right? The first is attestation. That is, you need to have this DAC certificates installed onto your device. And then we have the Matter certification, which is required to be uh, used with the different ecosystems and validate your um, performance of the device, right? So these are the three categories on which we have tried to give our solutions in. So suppose you are doing a custom application development, right? That you want to write your full complete application from scratch, which is a very typical way of developing a product, right? So for that, we have quite a variety of solutions, which is basically our own ESP Matter SDK, which is built on top of the chip tool SDK, and it supports all the latest device types. Talk a bit more about it later. Then we also have our thread border router SDK, as well as a thread border router board, which is now certified to be an OTBR with the FreeRTOS running. And we have products which are already built using those hardware, as well as the thread border router SDK. And then we have our own Matter fabric and controller implementation using the ESP Rainmaker. From the attestation side, we have quite a few approaches or solutions for customers with different or varying needs. So one is the Matter pre-provisioning of modules, which is basically we pre-provision modules before we ship them to you. Then we have the customer factory DAC, which basically means we enable your factory to install or write or generate your own DACs and put them on your device. And then we have a new upcoming announcement about the in-field tax. Suppose, so those were for the custom application where you want to do the complete application development yourself. But we do realize a lot of customers don't want to do the Matter side of application development, and they maybe only want to do their own custom application for just their hardware related parts, or maybe just something like some very specific protocols or some very specific proprietary algorithms which they have. They want to just maintain them, but they are not worried about the overall in general Matter or the networking application, right? So they want to outsource it, right? So for those, we have a few solutions for the low-code development, which include ESP Matter Low-Code, the AWS IoT EXL module, and the ESP Hosted Zero-Code modules. We will talk about them later. So these are a few new offerings which we have. And then along with all these application development, right? So these were just covering the development and the attestation parts, right? So we do have services to provide the certification and validation. So we have a full complete certification assistance program, which will help you to complete and get the Matter certification. And then we have a Matter QA to Go program, which is basically a quality assurance program in which we can do a lot of tests in our device, in our labs, which are totally automated. We will see their coverage as well as the ecosystems which we cover for those validations. And then we have what we call the ESP Zero Code, which is a no code application. So, which basically means you don't have to write any code, you just have to maybe configure your devices. On the hardware side of view, that you just tell which device is connected to which pin is connected to which driver side, and then your device ready. They come in two flavors. One is the ESP Zero Code, the other is the ACK Matter Zero Code, which is based out of the Alexa connected for Matter SDK. Okay, quickly about the ESP Matter SDK. So ESP Matter SDK is built on top of the chip tool, open source chip tool SDK, which is the Matter SDK. It's based on the ESP IDF. So it has simplified APIs as compared to the open source Matter SDK. It has the device support for all the devices up to version 1.3 in the ESP Matter SDK release 1.3. The master branch for this also has the updates for the device type, which will be supported in Matter 1.4. There are production ready examples for quite a few device types, which can be directly used to implement those devices or can be used as reference for building your application on top of them. Then we have a thread border router implementation. We have Matter bridges for Zigbee, BLE Mesh, ESP Now. So yeah, so we have quite a few examples there as well. It is updated to support Thread 1.4 as well, which was just recently released. And then we have the integration with ESP Rainmaker for our complete Matter Fabric ecosystem as well. We did talk about the ICD briefly. So, yeah, as to mention, we do support Matter ICD devices, USB, the ESP Matter data model. Currently, it is available for ESP32H2 as well as the C6 in both SIT and LIT mode. Of course, since we two devices are really not meant for real low power devices, but they can still meet a very significant reduction in current consumption if you use them in the SIT and the LIT mode. Of course, we can receive further power consumptions when we have the ESP32H4. Okay, next we have the Matter Fabric and controller. So just to give you a highlight on what is a Matter Fabric. So a Matter Fabric is basically a virtual network of Matter devices that can communicate with each other. So all devices, including your phone apps, which basically links to the users, are part of this fabric, and a Matter Commissioner adds new devices to a fabric. So this is how a fabric looks like, and there are some implementations, different types of implementations around it. One of them is cloud associated. So the fabric in the cloud allows association of devices with users and carry those associations across sign-in on any of your devices. So basically, it can sync your devices across different sub-devices or controllers which you have on your Matter Fabric. With your own fabric, device makers can actually provide a complete experience and ecosystem to the consumer using their own and third-party Matter devices. A Matter controller. So it is typically a device which is in home and is in an always on state, and that helps to control and manage other Matter devices through touch or any other user interface or voice kind of control. It basically facilitates the local control, remote control, as well as OTA updates for these devices. It's basically the main device which will act for you to enable the remote control. So if once you are not in home, right, how do you communicate to your Matter devices which are only working on the local network? So it is through the controller, right? So with ESP Rainmaker, we have a complete implementation for a Matter fabric. So what it comes with phone apps with commissioning and control features. It comes with a PKI infrastructure for NOC signing, which basically whenever you have a new device onboarded, you are able to share your NOC credentials for that device. It synchronizes the ACLs on the cloud across your multiple device logins, and then it has a controller support for remote control management. So ESP Rainmaker does provide a full Matter Fabric implementation, which includes the phone app supporting commissioning and local control using Matter. Next, we will talk about the different attestation services, which we have, primarily the three. The first one is the module pre-provisioning. It is something which we already did cover in the previous session. So Espressif is a CSA approved PAA, which basically means we can issue DAC certificates for devices which are Espressif SOCs, and that is what we are limiting the service right now to. The modules and the SOCs are locked to protect those private key before being shipped to the customers. We are programmed with the unique passcode and the verifier that can be used to scan the device QR codes. When the customer receives these devices pre-provisioned along with the database of the module IDs as well as the certificate and the passcode for that. The next one is customer factory enablement. So this is basically we have now the option to enable customer factories to perform Matter manufacturing. So basically it has the ability to securely deliver cryptographically signed DACs to modules without their private key ever leaving the modules. How it is done is the device maker places an order to the Espressif DAC service, and then the device maker will share the order details to their factories. The factories will in turn do a signed DAC request, and then the Espressif DAC service will issue those DACs to the factory. Similarly, we have recently also launched the in-field device DAC update. So this is very interesting. So it basically delivers DACs to already in-field devices, which are already manufactured. And that can basically enable remote Matter support. So basically, if you already have a device which is in the field and you want to upgrade it to support Matter, it is now feasible. So for this, the devices must have a mutually authenticated secure connection to a known cloud platform. The cloud platform is expected to act as the trust broker for these devices. So how this works is a bit similar to how the manufacturing enablement works. So we first receive an order from the manufacturer, and then the manufacturer will configure its device cloud, and then the same time the device cloud will sign the DAC request which was received, and then we will have the DACs issued to the cloud platform, which in turn will deliver those DACs to the device via an OTA. Okay. Next, we have certification assistance. So certification assistance service is a service which we provide to help customers carry out their product certification, benefiting from Espressif's experience of Matter certification. We have done more than 150 devices now to be certified. So yeah, we do have some experience, and of course we have worked with labs to assess those certifications. So the customers who require this assistance can come to us. We will run the pre-certification test runs in our own laboratory to ensure that the product passes all tests before we deliver them to the ATL. And then, of course, the customers can also get a benefit of a pre-negotiated rate from the ATLs if they want to go for the certification directly. Okay. The next service we want to talk about quickly is the Matter QA to Go. So QA to Go is basically a quality assurance services. So it's pretty impressive, I would say. What we have here is that we have a completely automated intense testing of devices in our labs. So it's fully automated yet reproducible. We This is freely available right now for all Espressif customers if they want to um, get this. It supports both Matter over Thread as well as Matter over Wi-Fi devices. The test reports are available through an online system along with labs and videos wherever there is a test failure and gets uploaded, and the log requires the serial console access. So what all it covers? It covers tests for commissioning, device control, OTA upgrades, multi-admins. It also does test negative testing to test the behavior for negative scenarios. Then it also does a test over a few days with different fabrics. It also tests in noisy environments for device discovery as well as control. And then it does ecosystem compatibility across Amazon Alexa, Apple HomeKit, Google Home, Samsung SmartThings, as well as ESP Rainmaker. Okay, next we will quickly talk about the ESP Zero Code and some of the modules which are associated to it. So ESP Zero Code is a Matter-enabled product development uh, which provides a hassle-free one-stop turnkey solution, right? So we do provide pre-provisioned, pre-programmed modules. We have more than 150 Matter certifications completed with Zero Code. We support both Wi-Fi and thread-based devices, and now we also support some hosted mode devices, which we will cover later. We support primarily a huge set of device types like lights, plugs, switches, fans, blinds, appliances like air conditioning or thermostats. So there are huge variety of device types which are already supported. Um, so yeah. So the ESP AWS IoT XL module so it basically provides both an AWS IoT core connectivity as well as Matter connectivity to your device using external module. So it's basically primarily supports simple AT commands based on a serial interface. Uh, and then you get out-of-box security, OT updates, as well as device management from your AWS IoT core. So it's basically uses the AWS IoT core Express Link specifications as well as the Matter specifications and combines both of them together and provisions them on this module, which you can just use to connect to your own host module, and you have your system which enables both Matter as well as AWS IoT core connectivity. So some of the software features includes simple protocol, which is based on the AT commands. It provides Matter and AWS IoT core connectivity. It provides OTA and device management, as well as out-of-box, ready-to-use modules. From the hardware side, it supports both connectivity over Wi-Fi or Thread. It supports secure boot, flash encryption, so there is definitely security is covered. It's a simple two-wire UART interface, so your host doesn't need to have a very complicated hardware development as well as any software commands. And since the device is a module which is already certified for most geographies, so yeah, it's really a plug and play solution. So the next one which we will have is the ESP zero code modules. It's a bit similar to the AWS IoT code, but it has slight differences in the sense that it is providing you plain vanilla Matter connectivity without any AWS IoT code connectivity. So it's a two-chip solution to enable Matter connectivity. So suppose you have your own device which you want to now make it Matter compatible. You just need to plug in this hosted zero code modules, which require minimal hardware and software modification, and it communicates over a full duplex simple serial interface, and provides commands over 80, like 80 matter start or 80 matter set attributes, 80 matter get attributes to just communicate, right? So it's a very simple application development. So its primarily use cases are for manufacturers upgrading existing device to smart connectivity. Then it will also helpful for device makers who have very specialized custom firmware for like dimming control or touch, which they want to run on their existing hosts and don't want to tamper with it by porting it to any other wireless module, right? So these kind of customers can definitely choose to have this two-chip solution with the host still running their specialized firmware, but the networking and the Matter firmware or the logic is running on the zero code module. And we do support different device types like lights, fans, thermostats, blinds, etc. It reduces the time to market with minimal development effort because you don't really have to worry about the Matter development phases. So you just have to connect your devices with a simple AT command. So it's very, very simple, and don't really bother about the nitty-gritties of Matter implementation. And of course, you can do have OTA upgrades for remote device management. So the next one is the ESP low-code modules. So the low-code, so till now what we talked about were the hosted mode devices, right? So there were like two devices. You have a host MCU, and then you have a connectivity module which acts as your Matter zero code module, right? But with the ESP low-code modules, they primarily work with products which have two cores, HP core and the LP core from our side. So supposedly the ESP32C6 right now and the ESP32C5 in future, and they can help accelerate product development with custom firmware and built-in Matter connectivity. So how they work is, so for example, if you look at this one, right, so we have the ESP low-code single chip solution enable Matter connectivity with full customization possible for the customer on the LP CPU. So the HP core for this will run the networking stack as well as the Matter implementation, and then it will provide hooks to the LP core with simple API calls to call those Matter and network hooks, and your application will run on the LP core. The LP core has access to all the peripherals, so there is no limitation in terms of what you want to do or which peripherals you can connect. So that gives the full flexibility, whereas you don't have to really worry about the Matter implementation or the networking protocols which run behind it, right? So you can focus on your application-specific firmware, and Espressif will handle all Matter and network complexities. The framework to develop custom firmware on the LP core is there with peripheral HAL drivers. So basically, you still have the same application development feel as you have with the ESP IDF for when you are developing your application on the LP CPU. And there is effectively a low latency interprocessing communication, which we have done using the ESP AMP framework. So yeah, so this is something which is upcoming. So I would like to use this webinar as a medium to announce it. That yeah, this is something which we are going to bring you in the ESP zero code portal, which is called the ESP low code modules. So the primary use cases are, it is ideal for manufacturers who have really some proprietary algorithms which they want to run on their hosts, on their for their applications, which now they can run on the LP core. The other major kind of use case would be some applications which really require real-time processing of or real-time requirements on the application, which could not have been achieved because the networking is also running on the same HP core. So that's why now we separate the application to run on the LP core, the networking running on the HP core. So your LP core, you can have your real-time requirements met. And then, of course, it's ideal with all these. So all this can also be done with a host plus a networking core processor, right? Which is what we have shown in the previous examples. But with this low code modules, we get the benefit that it is running on a single chip. So it basically optimizes your design as well as your cost. You can run the same different device types like lights, fan, thermostat, blinds, depending upon whichever application you want to develop to. The custom firmware on the LP core is basically optimizes resources and components, lowering the R&D and the BOM cost while maintaining the flexibility in your product differentiation. So yeah, with this, we will come to an end of our webinar. We are open to any further questions now.
Thank you so much, Anand, for your amazing talk. Now we have more colleagues here, so I would like just to welcome you guys, Rishkesh and Shu. Thank you so much for being here. Now we have some time for the questions. We have a couple of questions here in the chat, so thank you so much for asking questions. And can we go to the first one? All right. So the first question we have is ICD same as sleep and device feature of thread standard?
Yeah, okay. So let me take this question. Yeah, so actually the ICD is the meta layer feature, but the sleepy end device is a low power device type defined in the thread standard. So actually, so they are not the same, but there's indeed some relationship between them. For example, as Anand just explained, the Meta ICD device can be configured to operate in either active mode or idle mode with different polling intervals. So for if it's a Meta over thread ICD device, the polling interval will be configured and managed by the thread layer. So the device will remain in sleep mode for most of the time and wake up to do the polling based on the configured interval configured from the meta layer. So yeah, the two is operated on different layers to combine them to build a sleepy end device. Yeah.
Thank you, Shu, for the answer. We have a couple more questions here. So the next one is, can in-field products be upgraded with Matter with Espressif's DAC service?
Sure, I can take that. So yes, Espressif is recently approved as a non-VID scope PA by the CSA. What it means is basically we can securely provide the DACs to our customers' in-field device through their cloud platform. So they definitely need a own cloud platform which will act as the base to be in contact with the devices and deploy those DAC certificates to those devices. Apart from that, we can now also provision the products in customer's factory as well. So
Yeah, thank you, Anand. One more question here, and the question is, will you do a certification for Thread 1.4? Currently, you are Thread certified for 1.3 uh, from May 2023.
Yes, of course. Yeah, so our current Thread platform is Thread 1.3 certified. And the Thread group has released the Thread 1.4 spec a couple weeks ago, I think. And the certification program is still ongoing. It's not published yet. So once the program is ready, we will do upgrade our platform to 1.4. Yes, so the answer, yes, of course. Yeah.
Thank you, Shu. And one more. Is ESP Rainmaker Matter available in India for proof of concept?
Pedro, I'll take this. So yes, the public ESP Rainmaker supports Matter. Along with that, the Android and iOS apps for ESP Rainmaker also support Matter. So if you can just download those from the app stores and try out the examples provided in the ESP Rainmaker repository, they should just work fine. Uh, One more point I would like to mention over here is that Matter being a industry standard, uh, vanilla Matter devices or only Matter devices will also get commissioned through the ESP Rainmaker phone app and hence get added into the ESP Rainmaker fabric. Whereas Matter plus Rainmaker devices can also be added.
All right. Thank you so much. So we have more questions in the chat, and I'd like to thank you, Ame, for answering the questions live in the chat as well. Um, so if you have any other question, maybe you can just ask here in the chat. We will answer later. This webinar will be available as well after the broadcast, so you can even ask question if you're not watching live. So guys, any other question you might answer from the chat, or we can just
I think there's
finish?
just a follow-up question now about the certification. Um, so, Shu, you want to take that? Yeah. I mean, do you know what is the timeline we will have for it?
Yeah, so yes, so actually currently the timeline is so the thread 1.4 spec is published, and the thread group is still preparing the 1.4 certification program. Basically at this moment the program is not ready. Yeah, but we will see once the certification program is ready, we will start to do the certificate for our platform, and we should be able to get our platform certified like within like 1 month once the certification program is ready. Yeah.
Thank you.
Yeah. By the way, but you can still ship Thread devices to the market with the current 1.3 certificate. There's no problem. Yeah, but if you are waiting for any new features in 1.4, yeah, so you can contact our support team and we can support you, yeah, offline. Yeah.
Thank you, Shu, for the clarification. So I like to thank you guys for answering the questions. Thank you so much. I know it's late for some of you, and yeah. So thank you again, Anand, for your amazing talk. Thank you, guys, and thank you for everyone who watched us today. And see you in the next webinar.
Okay. See you. Bye.